Key concept 7, target A.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
Example 1. Determine if each of the following conditional statements is true or false. If false, then explain. Now, remember, a conditional statement will be in the form if, then. The if portion being the hypothesis, the then portion being considered the conclusion, right? So for these, we have to determine if it's true or false. If it's true, it needs to be true 100% of the time. If you can even think about one example, one scenario where the statement would be false, then that means the statement is automatically false, right? A, if you are on the third floor of the FC, then you must be in goal 3. So if you are on the third floor of the FC would be our hypothesis, which we would give the letter P. Our conclusion would then be, then you must be in goal 3, which is Q. Now, while it is true for a lot of students, especially for all the 120 students in goal 3, it's not true for everybody. Okay, you can be in green 3 or blue 3 or maroon 3. So this statement would be false. And again, it says if false, explain. So false, you could be in blue 3. Okay, you do not need to give all the examples of where it's not true. One would suffice. Okay? The next statement says if the number is 14, then it is divisible by 2. If the number is 14 is our hypothesis, and our conclusion is going to be, then it is divisible by 2. What it means for a number to be divisible by another is that not only can you divide it, but there's no remainder, so it goes into it evenly, right? 14 divided by 2 does give you 7 no remainders, so sure enough, 14 is divisible by 2, so this would be true 100% of the time. All right, C, if you live in Cicero, then you live in Illinois. If you live in Cicero is my hypothesis P, then you must live in Illinois is my conclusion Q. Right? Now, for just about everybody who lives in Cicero, it's true. And sure enough, yeah, if you live inside Cicero, you must live in Illinois. Now, there could potentially be other cities in different states named Cicero, but right now we're assuming that the only Cicero in the United States is in the state of Illinois. So this would be true 100% of the time. Okay. The next one says, if a figure has 4 sides, then it is a square. If a figure has 4 sides as my hypothesis P, then it is a square as my conclusion Q. Okay. Now, sure enough, if we are talking about a square, it does have 4 sides, but a square is not the only figure that has 4 sides. Rectangle, a rhombus, a parallelogram, a trapezoid. There's so many other options, so since it's not true 100% of the time, it's going to be false. And remember, for false, you need to explain, and one counterexample is enough. So we'll say false. It could be a rectangle. Example 2. Name the property that justifies going from the first statement to the second statement. All right, so for A, notice we only have one statement. We're told that the line segment AB is congruent to the line segment BA. Okay, remember this little dash on top is not a line because it doesn't have arrows, so it stops in both directions. That is a line segment or a piece of a line. We're told that it's congruent. This symbol right here, equal sign with the little curvy on top, means congruent. Okay, now what it means to be congruent is for them to be the same size, length, or shape. In this case, because we're talking about 2 line segments, we're saying that they have the same length. Now, you'll notice that the first one is named AB and the second one is BA. So essentially, they're the same exact line segment. In fact, the only thing that it looks like occurred here was that it got reflected over. So it got flipped over, but it looks exactly the same. So I'm telling you here that AB is congruent to BA. So if you want to draw a picture here for yourself, like a visual, you can say here's A, here's B. So if we start up top here and we go in that direction, sure enough, we would label it AB. But if we decided to start here and go in the opposite direction, we could call it BA. But notice that it is the same exact line segment. Okay, So this is what we're going to call the reflexive property. Okay, which basically states that you're saying that something is congruent to itself. So in this case, I'm saying the line segment AB is congruent to itself, which makes sense. It's the same exact one, right? Now for B, the first statement is angle A is congruent to angle B, and then angle B is congruent to angle C. So I'll start with angle A. I'll give it a circle, all right? I'm going to give angle B a square. Here's angle B again, so I'll give it the same square as before, but now I'm telling you that it's congruent to a completely different angle, so I'll give that one a triangle, okay? The last statement they say is that angle A is congruent to angle C. Now, you'll notice that we said A was congruent to B, and that B is congruent to C. Notice that both of them are congruent to B. So if they're both congruent to B, they must be congruent to each other, which is exactly what we say here. Angle A is congruent to angle C, and that's what we call the transitive property. So when you have two things and they're both equal or congruent to the same item, they must be congruent to each other. So because A and C both happen to be congruent to B, they must be congruent to each other. It's like saying John has the same shoe size as Mary, and Mary has the same shoe size as Raul. So because they both have the same shoe size as Mary, they must have the same shoe size as each other. Example 3. Write down the conclusion, if any, which can be made from each of the following statements. Okay. Notice the directions here are not to write if it's true or false. We're not trying to determine that. We're just trying to determine what conclusion can I make at the end of these sentences. The first one, A, if I take more notes, then I can do my homework. Notice that first sentence is a conditional statement. It's in the form if, then. If I take more notes will be my hypothesis P. My conclusion is, then I'll be able to do my homework. So we give that the letter Q. All right. We move on to the second sentence. If I can do my homework, then I will get a good quiz score. Again, that statement is a conditional one because it's in the form if, then. If I can do my homework would normally be my hypothesis, and it is, which means we should give it the letter P, which we normally would. However, you can notice that that sentence is similar to the last part of the top one. Then I can do my homework. So because it's similar, we'll leave it as the letter Q. All right. Now, my new conclusion will be, then I will get a good quiz score. Since we already went P to Q, so we'll go to Q to R. We introduce a new letter, all right? So this is basically saying, I started with P, P led to Q. Now that I'm at Q, that led to R. So I'm interested in where did I start, P, and eventually where did that lead me to, R. So I should then write, if P, then R. Okay, so if I take more notes, ultimately what will happen is that I will get a good quiz score. Then I will get a good quiz score. Okay. Now moving on to B. B says, if I wake up late, then I will miss a school bus. That is a conditional statement. It's in the form if then. If I wake up late as my hypothesis P, what's going to happen is I'm going to miss a school bus. Okay. Now, notice in that first statement, I'm telling you what will happen. I'm predicting a future event. I'm telling you, if you tell me that you wake up late, then what's going to happen for sure is you're going to miss a school bus. All right. The second sentence, I wake up late. Notice that this is not a conditional statement because it's not written in the form if or then. Now I'm telling you for sure what happened was your hypothesis. You woke up late. So what's going to come after that is you're going to miss a school bus. So the conclusion is I will miss a school bus. Okay. Last one. If I live in Cicero, then I live in Illinois. If I live in Cicero, is my hypothesis. We'll give it the letter P. Then I will live in Illinois is Q. Okay. So I'm telling you, if you happen to live in Cicero, then for sure you live in Illinois. Now the next sentence is not conditional. It's not in the form if then. I'm telling you that your conclusion from before actually happened. You do live in Illinois. Okay. Does that automatically mean you live in Cicero? It does not. Okay. Now, for a lot of you, it might mean that. And for a lot of you, it does mean that. But not everybody. I live in Illinois. I could also live in Stickney or Oak Park or Berwyn. So there's other options. Okay. So because we don't know for sure that you live in Cicero, for this one, we're going to end up saying that there's no conclusion. Okay. Remember that with a conditional statement, what I'm telling you is that if P happens, Q follows. If P does happen, then what follows will be Q. But if Q happens, that doesn't necessarily mean that P will follow, right? So it doesn't work in reverse. If you remember our discussion in class, sometimes when the initial statement is true, you flip it around and automatically you end up with a false statement, okay? And sometimes that works in reverse too. So if you end up with something that's false to begin with and you flip it around, the hypothesis and the conclusion, you might end up with what is a true statement. So you gotta be very careful when you move those things around. Example 4, error analysis. Your friend rewrote the following statement: you bike every Friday afternoon, as a conditional statement. If you bike, then it is Friday afternoon. What is your friend's mistake and correct? All right, so the title was error analysis. So we're analyzing, we're observing a mistake, we're trying to figure out what went wrong. We have two parts to do here. We need to figure out what the error is and then correct it. So keep in mind, the original statement is this one right here. You bike every Friday afternoon. Okay, so 7 days out of the week, let's say today is Sunday. There is a possibility that we bike, but we don't know for sure. Same thing with Monday, same thing with Tuesday, same thing with Wednesday, same thing with Thursday. But now comes Friday. For sure, we are biking today because it's Friday. That's what it says right here. You bike every Friday afternoon. So without miss, if it's Friday afternoon, that's it. You're biking. Okay. We go into Saturday. Saturday, there's a possibility, but it's not for sure. Right. Now, our friend rewrote it like this, which we're told is incorrect. So this is wrong. This one says, if you bike, then it has to be Friday afternoon. Okay. We don't know that for sure. It could potentially be a different day. So first thing we're going to do is we're going to go ahead and correct it. And then from there, we'll figure out where our friend went wrong. Right? So we want to rewrite the yellow statement in such a way that it is true every single day. Now notice in that yellow statement, you bike every Friday afternoon. The only thing that we are sure of is that on Fridays we bike. So we'll start with, if it is Friday afternoon, then we know for sure what we're doing is biking. So if it is Friday afternoon, then you bike. Okay, this is the correct way. Okay, so what is your friend's error and corrected? We corrected it, now we just got to fix that, what went wrong. Okay, notice ours looks similar to the red one that was wrong, except we switched it. So their P before was if you bike. We made that our conclusion. Their conclusion before was if it's Friday afternoon. We made that our hypothesis. So the mistake here was switching the hypothesis and the conclusion. My friend's error or my friend's mistake was switching the hypothesis and conclusion. Then I might add one more statement to that. The reason this is so incorrect was because the way our friend wrote it made it seem that the only day we could bike was Friday, and that's not true. Okay, so we could be biking any other day. There is a possibility of biking on another day that is not Friday. Okay, so now we've officially corrected the mistake and we identify what was wrong with that. Example 5, error analysis. Your teacher makes the following statement. If you receive bad grades, then you won't go to college. Lisa's not going to college, therefore Lisa must have received bad grades. And then we're asked if the teacher's conclusion is true, why or why not. Okay, so if you receive bad grades, is our hypothesis P, then you won't go to college is our conclusion. Okay, it's missing the word then, but it's still a conditional statement in the sense that I'm telling you that if this happens, what follows is you won't go to college. So if you receive bad grades, you're not going to go to college. Okay, the next sentence says Lisa is not going to college. So this sounds a lot like our Q from before. Okay, the only difference is that before it was more general. I'm saying no one's going to go to college. Now I'm specifically saying that Lisa's not the one going to college. So the next sentence, therefore Lisa received bad grades. That sounds like a lot like our hypothesis from before. So it's our P. It's our P. Okay. For this one, I think of the real obvious one. So if you live in Cicero, then you live in Illinois. 100% true. However, if I turn it around, if you live in Illinois, then you must live in Cicero, is no longer true. Same thing here. If you receive bad grades, then you won't go to college. We'll accept that one as true. Lisa's not going to college, therefore Lisa received bad grades. There is no way we know that 100% for sure. So we can't assume that just because Lisa's not going to college, that she received bad grades. There might be other reasons. So we're going to have to answer the question if our teacher's conclusion is true and then why or why not. So we can say the teacher's conclusion is not true, or we can say it's false. Is false. And then the second question was why or why not. So the teacher's conclusion is false. There might be other reasons Lisa's not going to college. And then just to further back up our statement, we're going to give an example. So, for example, she might have decided to take a year off. Okay, we don't need every single possible explanation for it, just one to show that, yeah, it doesn't necessarily mean that because she's not going to college, she got bad grades. So, for example, she might have decided to take a year off. All right, so we answered the question if our teacher's conclusion is true, and we explain why or why not it was. Example 6, given the following statement, all freshman students with 5 credits move on to their sophomore year. Second sentence says all Gold 3 students have 5 credits. A says write the first sentence as a conditional, and then B says draw a conclusion based on the statement. If not possible, explain why. So A, write the first sentence as a conditional. So first sentence, all freshman students with 5 credits move on to their sophomore year. The task is to rewrite that as a conditional statement. So rewrite in the form if, then. There's a condition, there's a conclusion, there's a hypothesis. So my hypothesis will be the first part. If you're a freshman student with 5 credits. If you're a freshman student with 5 credits. Okay, so there's my hypothesis. My conclusion is then you're going to move on to sophomore year. Then you'll move on to sophomore year. Okay. If you're a freshman student with 5 credits, then you'll move on to sophomore year. All right. Now the next part, B, says draw a conclusion based on the statement. If not possible, explain why. So the second sentence we still haven't talked about. all Gold 3 students have 5 credits. So the first part A just said that if you are a freshman student with 5 credits, what's going to happen is you move on to sophomore year. Now I'm telling you specifically, hey, all the students in Gold 3 do have 5 credits, which means they're going to move on to sophomore year. So all Gold 3 students will move on to sophomore year. And we answer both parts now.